Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this session we are going to find out the value of this integral, that is from minus pi by 2 to pi, and our integrand is mod of x plus mod of cosine x, right? So here our integrand, it comprises of the sum of two mod functions, mod of x and mod of cos x. So let us call this integral as I. Now since here we have a mod function, so we'll utilize the definition of mod function to get the value of this definite integral. Now see, the definition of mod function goes like this: mod of p is equal to a positive p whenever p is greater than 0, mod of p is 0 when p is equal to 0, and mod of p is minus p when p is less than 0, right? So we are going to use this definition of mod function to simplify this definite integral. Now here, apart from using the definition of mod function, we'll also make use of the sign convention of trigonometric functions in four quadrants. So let us see the sign convention for cosine function in the four quadrants. So here we have the quadrants. This is first, this is second, this is third, and this is fourth. Here we have 0. Here we have pi by 2. This is pi. This is 3 pi by 2. And here we have 2 pi. Right? Now see, we know that the cosine function is positive in the first quadrant, it is negative in the second quadrant, it is negative in the third quadrant, and it is positive in the fourth quadrant. So now let us see the limits of integration. So here the lower limit is minus pi by 2 and the upper limit is pi, right? Now from trigonometry we know that it is a convention that when we measure an angle in anti-clockwise direction, then it is taken as positive, and when we measure an angle in clockwise direction, then the angle is taken as negative, right? So here we have the lower limit as minus pi by 2, right? So when we go from this line, that is the 0 degree towards 3 pi by 2 in clockwise direction, then this angle is minus pi by 2, right? And here the upper limit is pi, right? So when we go like this up to from 0 to pi, then this angle is taken as positive angle, that is positive pi. And when we go clockwise from 0 degrees to 3 pi by 2, then it is taken as negative pi by 2. So now let us split this integral as a sum of three integrals. So here we have the lower limit as minus pi by 2 and the upper limit is pi, right? So between minus pi by 2 and pi, we have 0 and pi by 2. So here we have 0 and here we have pi by 2. So first we'll go from minus pi by 2 to 0, then from 0 to pi by 2, and then we go from pi by 2 to pi. So now it is interesting to note that when we travel from minus pi by 2 to 0, then we are in the fourth quadrant, right? And when we go from 0 to pi by 2, then we are in the first quadrant. And when we go from pi by 2 to pi, we are in the second quadrant. And remember, when we are in the fourth quadrant, then the cosine function is positive, cos x is positive, and when we are in the first quadrant, cosine function is positive, and when we are in the second quadrant, then the cosine function is negative, right? And here we have mod of x. So when we go from minus pi by 2 to 0, then mod of x, that is mod of x is equal to a negative x, because in that case all the angles which are which falls in the fourth quadrant are negative, right? So we have mod of x is equal to a negative x, and when we go from 0 to pi by 2, all the angles are positive, that is mod of x is positive x. And in the second quadrant also the mod of x is positive x. So now using the definition of mod function, we can now write mod of x is equal to negative x when x belongs to this interval, that is minus pi by 2 to 0, right? And mod of x is positive x when x belongs to the interval, that is 0 to pi by 2, and when we go from pi by 2 to pi, then again mod of x is positive when x belongs to the interval, that is pi by 2 to pi, right? And similarly we can define cosine function mod of cos x. So mod of cos x is positive cos of x when x belongs to this interval, that is when x belongs to the fourth quadrant, and mod of x is positive cos x when x belongs to the first quadrant, and mod of cos x is negative when x belongs to the second quadrant. So now I can be written as minus pi by 2 to 0, and then here we have mod of cos x. So mod of cos x is negative x, and mod of cos x is positive cos x, and then we have the integral from 0 to pi by 2, that is in the first quadrant. In the first quadrant, mod of cos x is positive, and mod of x is also positive, so we have plus x, and here we have positive cos x. And when we go from pi by 2 to pi, then mod of cos x is again positive x, and mod of cos x is negative cos of x. So now we have to evaluate these three integrals. So let us call these integrals I1, I2 and I3. So I1 is minus pi by 2 to 0. Here we have minus x plus cos of x dx. Now the integral of x is x square over 2, and here we have the integral of cosine x is sine x, and the limits are from minus pi by 2 to 0. Now first we'll take x is equal to 0, then we'll take x is equal to minus pi by 2, and then we'll take the difference. So when we take x is equal to 0, this term is 0, this term is 0, because sine 0 is 0. So here we have 0, and then we have minus pi by 2, so this is minus pi square over 4 divided by 2, and here we have sine of minus pi by 2, right? So this is minus pi square over 8, and here we have minus sine pi by 2, because sine of minus theta is minus sine theta. So now here we have sine pi by 2 is equal to 1. So we have plus pi square over 8 plus 1. So multiplying these two numbers with the negative sign, we have pi square over 8 plus 1. So this is the value of I1. Now let us find out I2. So we have I2 from 0 to pi by 2, and here we have x plus cos of x dx, and the integral of x is x square over 2, integral of cosine x is sine x, and limits are from 0 to pi by 2. So taking pi by 2, here we have pi square over 4 divided by 2 sine pi by 2 minus, and when we take x is equal to 0, then this term is 0, this term is 0, because sine 0 is 0, so here we have simply 0. So this is pi square over 8 plus 1, because sine pi by 2 is 1. Let us find the value of I3. I3 is pi by 2 to pi, and here we have x minus cos of x dx. So again here we have x square over 2, and here we have sine x. The integral of x is x square over 2. The integral of cosine x is sine x. Limits are from pi by 2 to pi. So first we'll take x is equal to pi. So we have pi square over 2 minus sine pi, and then we have the negative sign, and then we take x is equal to pi by 2, pi square over 4 divided by 2 minus sine pi by 2. So here we have pi square over 2, sine pi is 0. So here we have 0, and here we have pi square over 8, and sine pi by 2 is 1. So now we can write pi square over 2, and here we have minus pi square over 8 plus 1. So now we can simplify this expression, because here we have these two like terms. So the LCM is 8. Here we have 4 pi square, then minus pi square plus 1. So this is 3 pi square over 8 plus 1. So now the value of this integral I is given by the sum of these three integrals I1, I2 plus I3. So here we have pi square over 8, pi square over 8, and 3 pi square over 8. So when we add all these three numbers, we get 5 pi square over 8, and here 1 plus 1 plus 1 is equal to 3. So the value of this integral is 5 pi square over 8 plus 3.